Okay, so I'll try to make this sort of fast because it's not really that difficult. Um, so it says during fifth period lunch, 85 of 280 students had milk as their drink. Based on those results, how many of the 1,390 students at school will drink milk? Okay. So in our experiment here, we've shown, or we got the result that, and I'm going to write it, the people who drank milk in our little experiment at fifth period was that 85 out of 280 had milk, right? So that was our um, based on real results, right? So we're going to take that and then multiply by 1,390. And that's going to give us a number of people that drink drink milk out of the whole school, right? So we're going to go, we can't simplify, but I'm just not. I'm just going to multiply across. I'm going to multiply 85 times 1,390. And I get 118,150, and then I'm going to divide that by 280. Divide that by 280. It's going to give me 421.96, but we can't have 421.96 students, so we're going to round that to 422. So out of the 1,390 students in school, 422 of them would drink milk. Okay, so we're using the results of experiment here, and the experiment was that we took a little, we asked all the 280 kids at lunch, or we saw them, right? And they chose 85 of them chose milk. So we used that to multiply by 1390. Okay. Next one. A bag of marbles contains 7 red, 8 green, 11 marbles. So the first thing you should do is always add them up. So we got 15 here plus 11. We got a 26 total. Right? So you should always get the total. Once you select the marble, it is not replaced. So if you take 2 marbles, the first one you take out, you keep it, and then you don't put it back. So this is then dependent, which means our total is going to change. Okay, so just keep that in mind. So first one says just what's the probability of getting a red one? Well, that's easy. 7 out of 26. We're not taking 2 marbles, we're just taking 1. Second question says not green. What's the probability of you putting your hand in there and not getting a green? Not getting a green with these would be these and these. Oh, okay. So let's make these blue marbles. Okay. I know it doesn't say. So let's just pick another color. So not getting a green would be this 7 red and these 11 blue. So 7, 11 would be 18 out of 26. And you do need to simplify on your test. 19 out of 13 would have been your final answer. What's the probability of getting a green or a red? So either a green. So if you pull out a green, you win, or pull out a red, you win. So one of the two. So that would be 15 out of 26. You're not taking 2 marbles here. You're taking 1. So it's either a red or a green. So just be very careful here. And finally, we get one situation where you're taking 2 marbles and you're not putting them back. So what's the probability of getting a red marble? Well, to get a red marble, it's 7 out of 26, right? Because there's 26 total. So I'm going to go back to the bag. So let me put the red one that I just took outside, which means that when I go back to the bag, and let me just erase this. When I go back to the bag, oh, this is blue, by the way. When I go back to the bag, there are no longer 7 red marbles. There's 6. So when I'm going to go back for the green, how many greens are there? Well, there are 8 greens, but how many marbles are here? It's 25 because the first one we took we'd not put back in the bag. There is, we can simplify here. Divide by 2 is 4, divided by 2, 13. And we get 7 times 4 on the top is 28, and at the bottom 13 times 25 equals 325. So the probability of you getting a red one and then a green one is 28 out of 325. And if you want to change that to a percentage so that you can picture that a little bit better, that would be about 8.61%. You have an 8.61% chance of taking the red followed by a green. Okay. So number 3, there's a 30% chance on Saturday of rain and 60% chance of rain on Sunday. What is the probability that it will rain all weekend? So we want to see what's the chance it's going to rain on both days. So there's 2 events happening, Saturday and Sunday. So remember, we're going to multiply the probability that's going to rain on Saturday times the probability that's going to rain on Sunday. So, but I'm going to multiply, well, you know what? The probability of rain on Saturday is 30%. Let me write that down. It's 30% times the chance of rain on Sunday is 60%, so I'm going to multiply it by that. But we're not going to multiply it as a percent, right? So you can change it to a decimal or a fraction. It's up to you. So I'm just going to change it to a decimal. So decimal will be 0.3 times 0.6. And if you multiply 0.3 times 0.6, you get 0.18. And depending on how the question is, your multiple choice answers, this you can change back to percent, and it would be 18%. So the chance of rain on both days. So remember, so think about it. So if you're, I don't know, betting, and in order for you to win, it has to rain on Saturday and on Sunday. So the chance of those 2 happening is 18%. Okay. Maggie flipped a coin 20 times and recorded the results below. So this is an experiment. This is an experiment, guys. All right. This is an experiment. Okay, so just keep that in mind. What's greater, the experimental probability or theoretical probability of flipping heads? Well, in her experiments, how many heads did she get? Well, 1, 2, 3, 4, 5, 6, 7, 8. So she got 8 heads in her experiment. Let's compare it to her theoretical. Theoretically, okay, so let's forget that question. So if I asked you, hey, if we were to flip a coin 20 times, how many times would we expect to land on heads, right? So the probability of landing on heads is a half. Times 20 would be 10. So theoretically, before this even happened, and you and I had the discussion, or Maggie and I had the discussion, we would come up with that, hey, you know what? We are expecting that it would land on 10 times. So theoretically, we were out of 20 times, we would expect to land on the head 10 times theoretically. Did it happen? No. In her experiment, she got 8. So which one was greater, the theoretical or the experimental? Well, the experimental was 10, and the theoretical was 10, and the experimental was 8. You can again talk about all this and explain use as evidence. Okay, so theoretically we were expecting 10, but in reality it came out to be 8 out of 20, and in reality, 8 out of 20 in the experiment, and we were expecting 10 out of 20 theoretically. Okay, you need to explain. This is going to be a part 2 question. Hint 5. There's 35 cars in the parking lot. 12 are black, 10 are silver, 5 are blue, and 5 are white, and 3 are green. Is that 35? 12, 15, 25, yeah, 35. If 2 cars are selected at random, what is the probability that both cars are black? So we want pre of black and then black. Right, so obviously you're not going to return the car. You're going to select 2 cars. You're going to take 2 cars out of the parking lot. So if you take a car out, you're not going to put it back. So what's the probability of getting a black car in the first try? Well, it's going to be 12, right? Because there's 12 black cars out of 35. So you take the car and you put it over here. Right, so here's a car. Now you're going to go back again and you want to select another car. Well, first of all, there's no longer 35 cars in the lot. There's 34. So, and remember, we put one of the black cars outside, so there's no longer 12 cars that are black. We have 11 cars in the lot that are black. So on the second try, we have 11 out of 34 chance of selecting a black car. Can we simplify anything? Yeah, we can. This becomes a 2. This becomes a 17. So on the top, we get 66. And at the bottom, 35 times 17 equals 595. All right, so the chances of you taking two cards that are black randomly is 66 out of 595. 7, what is this? There are 14 candies, piece of candy, 4 are broken. So I can write this that 4 out of 14 are broken. So 4 are broken out of 14. Okay, which means that 11 are not broken, right? So I have 14 pieces of candy and 4 are broken, 11 are not broken. So, all right, so I just answered the question. So what's the probability of reaching the bag and taking a candy that's not broken? Well, right here, 11. 11 out of 14 chance that you can go in the bag and select one that's not broken. 7, here's a little survey. So they walked around, asked people what their eye color was, and here are the results. So according to this experiment here, what's the probability, experimental probability, that a student has hazel eye colors? Well, first of all, we got to find the total. So let's add them up. See how many people were asked. 12 plus 58 plus 2 plus 8 equals 80. So out of the 80 students that we interviewed here, how many had hazel eyes? 8, or 1 out of 10. 1 out of every 10 students asked had hazel eye colored. Okay, so let me write this, P of hazel. Now, we're going to use this, right, our experiment here, to predict if we go around and ask another 400 students, let's predict how many of them would also have hazel eyes. So, based on this, so we can use 8 over 80, or 1 out of 10. Hope you use 1 out of 10, so we're going to take that. And multiply by 400 to predict. So we're going to use the results of our experiment to predict the next 400 students, how many of them would have hazel eyes. So multiply that 1 times 400 and then divide it by 10, and you obviously are going to get 40. So out of the next 400 kids, 40 of them will have hazel eyes. 8. Maria flips a coin 20 times. It lands on tails 9 times. According to theoretical probability, how many more times would Maria have expected to land the coin? So let's talk about this. So before you even flip a coin 20 times, what's the probability on landing on tails? The probability to land on tails is a half, right? So now we can take that probability and multiply by 10, 20 to predict how many times it will land on tails, right? So half times 20 is 10 times. So before the experiment, let me write before the experiment, and we talk about it, Maria and I talk about it, we are going to say that, hey, you know what? We're going to expect that the coin lands on tails 10 times. She does the experiment, and the coin lands on tails 9 times. So how many more times did Maria expect to land on tails? Well, she expected to land on tails 1 more time, right? Because it landed on 9, and she was actually expecting it to land on 10. So it needed to land 1 more time so that they both match. Okay. 9. Marvin has 20 marbles. 8 clear, 4 blue, 5 yellow, 3 black. What's the probability that it's going to take 3 marbles? 3 clear marbles out of the bag in a row, and he does not put them back after he takes one out. So we want a probability clear, then another clear marble, and then another clear marble. Okay, so we're going to multiply 3 events here. You just got to be very careful with what you write down. So let's add them up. Well, there's 20, I know, right? So, and how many are clear? 8 marbles are clear. So on the first try, well, first we know that there's 20. I reach in the bag, and there's 8 out of 20 chance that I get a clear marble. I get the clear marble, and let's just use this clear marble right there. Put it on the side. So let me go write this, that there are no longer 8, there's 7 marbles inside the bag that are clear. So on my second try, I go in the bag. Remember, I took one out, so there's now 19. And how many clears? Well, there's 1 less as well. Instead of 8, now there is 7. Okay, so let me put the second clear marble that I just took out of the bag. So there's no longer 7, but now I have 2 less, which is 6. On my third try, I go in the bag, and I want to pick another clear marble. Well, what's the total right now? Well, 2 marbles are aside, so I know there's 2 less, which is 18. And how many clear? Well, we had 8. We took 2 out. We now have 6. Now it's just seriously a matter of multiplying and figuring out. So if you can simplify before, so this becomes 1/3. This becomes 2 divided by 4 is 2/5. So it's a little bit easier. So on the top, 2 times 7 times 1 is 14. At the bottom, 15 times 19 is 285. So that's the probability of you achieving that, taking 3 clear marbles out of the bag, one after the other. 10. There is a 0.05% chance that we'll have an earthquake. What's the probability that we'll not have an earthquake? Well, this depends on 0.05, right? So let me try to make this a little bit easier. So 0.05 as a percent would be, if you move that 2 to the right, move it 2 over, it would be 5%. 5% chance of earthquake. So what's the complement? The complement is 100%, right? 100% would be the total percentage minus 5%. So in other words, there's a 95% chance, the complement, 95% chance of no earthquake. Okay. So now our question, first of all, was in what kind of form? Was a decimal format, right? 0.095. So if we want to change 95% back to decimal, it would become 0.95. So we can say that 95% chance of no earthquake, or 0.95 chance of no earthquake, depending on what notation you want, percent or decimal. Okay, but that's what the question is asking. 11. 80% of all Californian drivers wear seatbelts. So not everybody wears a seatbelt there. Don't know why. 4 drivers are pulled over. What's the probability that all 4 will be wearing the seatbelts? Okay, so again, this is an event. There are 4 things that we're going to be multiplying, right? So 80%, by the way, let's just change that to a percent, to a decimal. That becomes 0.8, right? So, or as a fraction becomes 8 over 10, or better yet, simplified, that becomes 4/5. So now we are not going to use the percentage to multiply, so I either can choose this or this. It's really up to you. So the first car we pull over, what's the probability the guy is wearing a seatbelt? Well, we can write the probability of him wearing a seatbelt right now. And let's just do this as a fraction. 4/5. There's a 4/5 chance he's wearing a seatbelt. Second guy we pull over, there's a 4/5 chance he's wearing a seatbelt. Third guy, 4/5. Fourth guy, 4/5. And we can multiply this all across. Right, so here we got 4 times 4 times 4 times 4, which is 256. And this is 525 or 625. 5 times 5 times 5 times 5, 625. So as a fraction, it looks like that. So if you want to change that to percent, just divide 256 divided by 625, and it would be 0.4096, which changed to 40.96%. So there's a 40.96 chance, 96% chance that all 4 drivers are wearing a seatbelt. So if you also wanted to multiply 0.8 times 0.8 times 0.8 times 0.8, you get the same answer. Okay. Just to confirm, and you get exactly the same answer, which you can then change to a percent if you like. Okay. So the one trick thing here, the one tricky part, I guess, was you knowing you can change either to a decimal or a fraction. And again, depends if this was a question that was a part 2 question, then you would have to choose either this should work or this should work. If it was a multiple choice question, then depends on what the answers were, right? In fraction format or percent format or decimal format or even percent format. Okay. 12. Kim wants to roll a die 300 times. She wants to. She hasn't rolled it yet. Okay. So how many times out of the 300 would we expect it to land on 4 or 5? And how many times would you expect it to land on number 1? Wow. So first of all, what's the probability of landing on P or 4 or 5? What's the chance that a die lands on 4 or 5? So you have a 2 over 6 chance, right, to land on 4 or 5. So, and if we take that and we want to see out of the next 300 times how many times it's going to land, we're going to multiply that by 300. So 2 times 300 divided by 6. So we expect that at this 300 times, it's going to land on number 4 or 5 100 times. How many times would you expect it to land on number 1? Well, what's the probability of landing on 1, first of all? It's 1 out of 6, right? So let's multiply that by 300. So if you were to roll that 300 times, you would expect it to land on the number 1 50 times. Expect. Okay. So again, theoretical, we didn't roll the die yet. Okay. All these cubes, once a cube is taken, it is replaced, so we're gonna put it back this time. Okay. So what's the probability of getting 2 yellows? Well, let's find the total first. 2, 7, 10, there's 15 total. So on the first try, we want to get a yellow, and it's going to be, well, you have a 5 out of 15 chance to get a yellow. You look at the yellow, you put it back in the bag. So you go for the second try. How many total you have now? Well, you still have 15 because you put that cube or marble back. And you want to go for a second yellow, and you have a 5 out of 15 chance again to select a yellow. So that becomes 1/3. This becomes 1/3. So you have 1 out of 9 chance to select 2 yellows in a row with replacement, meaning after you take the first one back, you put it back in. It's the probability that you get something that's not blue, and then you get a blue. Well, first of all, there's 15. Something that's not blue. Not blue would be this, this, and this. So anything but blue. 2 and 5 is 7. 7 and this 5 is 12. So you have a 12 out of 15 chance of getting something that's not blue. So you pick one, look at it, put it back in the bag, and you go for the second one. And the second try, you want to get a blue. Probability of getting a blue, well, how many blues are there? 3 out of 15. Remember, since we put this back, the first marble back in the bag, this is an independent event. So let's simplify. And we got 4 out of 25. So probability of you achieving this is 4 out of 25. Ew. 14. 14. All these textbooks on the desk, and you want to select 2 random books. What are the probability you get 2 science books? So what's the probability of 2 science books? So because you're selecting 2 science books, this is one where you take one and you don't put it back because you actually want to take away, right? 2. So this is dependent because the total is going to change. So the probability of getting a science book on the first try, well, how many total are there? 5, 8, 13. There's 15 textbooks again. And the probability of getting a science book on the first try is 5 out of 15. So let me put the science book here on the side, the first one. I go back in the bag. There's no more 4 on the desk, not bag, but they're on the desk, right? So 1 is gone. So now there's 4 textbooks, 4 science textbooks on top of the dash. So the probability of you getting a second science book is 4. And remember, the total changes to 1 less, 4 out of 15. Multiply, 1/3, 2 out of 7. And you get 2 out of 21. Which number does not represent the probability of an event happening? So remember what probability goes. It starts at 0 and goes to 100% in percent format. In decimal format, you go 0. Okay, so let me write this 50%. This will be 0, 0.5, 1. And in fractions, 0, a half, and also 1. So nothing passes 100%. So fractions have to be between 0 and 1. Okay. This is definitely a fraction bigger than 1, so that's gone. This decimal is definitely bigger than 1, so that's also gone. 250% is definitely bigger than 100%, so that's gone. So the only one that's between these two, the ranges here of 0 and whatever here at the end, depending on whether it's percent, decimal, fraction, the only one that's in between is 0.04. 0.004, it's right about here. Very tiny, tiny, tiny chance of happening. So this is the only one written in the correct notation, because probability has to be between 0 and 1 or 0 and 100%. Okay. 16. Tim arrived to work 2 times on the Tim arrived early to work 2 times on the last 10 days. What's the probability he will be early to work tomorrow? Well, to find the probability of him coming early tomorrow, we're gonna look at his past, right? So let's look at his past record, and that would be the experiment, right? We're using what he did previously to determine the probability of tomorrow or not, okay? So in the past 10 days, so we have a record here. In the past 10 days, he was early 2 out of 10 times, or we simplify that, 1 out of 5. If you want to go even a step further, that becomes 20%. So depending on what your question answer is in fraction format or percent tomorrow, or if it's a part 2 question, you're going to write the tomorrow. He has a 20% chance of coming to work early. Okay. So I have to put your bonus word at some point. Okay, so here we go. Census. Oops. 2020. Census 2020. "17. Based on the experiment below, what's the probability that the next roll will be a 3? Well, this is the experiment, right? Let's find out how many times you rolled first of all. So 11 plus, so I gotta add all that. 11 plus 10 plus 4 plus 16 plus 9. So there were 50 rolls total. Always make sure you get the total. So based on this experiment, the probability of rolling a 3 was, how many times did it land on 3? 4 out of 50. Or if you simplify, 2 out of 25. So based on the experiment, the probability of landing on a 3 is 450 or 2 out of 25. So we're going to take that to answer the question. If Sam wants to roll the dice 600 more times, how many times should she expect a 3? So we're talking about based on the experiment. So in the experiment, the chance of landing on 3 was 2 out of 25, and we're going to take that and multiply by 600. And we get, divided by 25, we're going to get 48. So based on the experiment, we're going to expect that it lands on 3 48 times. Okay, on the experiment. 18, how many different outcomes are there when you roll a die, toss a coin, and roll another die? So when you roll a die, there's 6 different outcomes. Times, when you toss a coin, there's 2 different outcomes, heads or tail. And when you roll another die, you have 6 different outcomes, right? 1, 2, 3, 4, 5, 6. So if you do all these 3, how many different things can you have? Well, 72. 72 different outcomes. 19, how many different pizzas can be created when you choose one from each category? Well, this is the same thing as the previous problem. So how many choices between here? Here I have 2 choices. I have a thin or thick crust. Times regular cheese or extra cheese. So again, that's 2 choices. Times pepperoni, sausage, or chicken. That's 3 choices. And times the last one, olives, mushrooms, or onions. So that's 3 choices. So somebody can come in and make a thin, regular sausage, onion. Somebody can have a thin, regular pepperoni and olive. Somebody can have a thin, extra cheese, chicken, and mushroom. So the total number of different pizzas that can be created here would be 36. You can make 36 different pizzas with this particular choices. Okay. All right. So 20. I really hope you guys get 20, and because it will be on your test a lot. They are going to ask you to compare the theoretical and experimental probability. I'll just fix this. Experimental probability of landing on green. So Sam spun the spinner 80 times. So there was an experiment here. In the experiment, the probability of landing on green, of getting on green, was 25 out of 80. 25 of 80 times it landed on green. Now, let's forget that for a second. Let's say I told you there was a spinner, and I told you we were going to spin that 80 times without doing it. So let's just talk about it. What's the probability of landing on green? So if you were to just look at this spinner right now, and I asked you what's the probability of landing on green, you would say, well, the probability of landing on green is 1 out of 4, right? Because one of them is green. And if we wanted to use that to predict what would happen in an experiment, so let's say, and if we were to spin this 80 times, 1/4 of 80 is 20 times. So theoretically, okay, so ignore this side for a second. Theoretically, just as a discussion right now, if we spun this 80 times, we are going to say, you know what? It should come out green about 20 times. That's what we should expect. And then we do the experiment. And in the experiment, we spun it 80 times, and it landed on green 25 times. So we can say a lot of things here. We can say that in our experiment, it came out green 5 more than we expected. We were expecting 20, but it landed on green 25 more times. So the experimental probability was a little bit more than theoretical probability. And that's what I need you to be writing down if this is a part 2 question. Okay. 21. At the beginning of the marking period, 78 students selected art, 65 selected dance, and 54 selected film. So, I know how you guys go to the auditorium and select, right, your FAPA. 78 plus 65 plus 54, enter. So 197 people. So obviously we still have other students coming. So right now 197 people were making their decisions, and these are the results so far. So what's the probability that the next kid who walks in the auditorium is going to select a film? Well, based on this, and again, based on this experiment, based on the actual results, based on something, the next kid who raises his hand and we ask him, what do you want? He, according to this, there is a, film, 54 out of 197 chance that he's going to select film. And if you want to put it in percent format, that equals to 27.4, 27 27.41%. So there's a 27.41% that the next kid was going to be called, and he's going to select film as his FAPA for the marking period. Okay, so this review and the one you did before this one should be more than enough, for you to ace the test. Okay, and that's it.